Hi Year 7. Today we're going to look at forces and just a quick introduction into what they are. We're going to look at different types of forces and we should be able to list the different ones. So our objective today is to be able to understand and explain what forces are, and like I said, we should be able to list some examples of different forces and also be able to draw force diagrams. So these are the questions that you'll find on your knowledge organizer. By the end of this lesson, we want to be able to draw some pictures showing push or pull forces. We want to be able to draw on arrows that show the direction. So these are what we call force diagrams. And we'll also be looking at a little bit more information using BBC Bitesize, and should be able to draw a lot more diagrams from that. So what exactly is a force? A force is anything that can be a push or a pull. We cannot see a force, but we can often see what it does. So for example, I have a picture here of two people playing tug of war, and they're both pulling on the rope. We can't actually see the force that they're applying to the rope, but we can see the action of that force. So eventually one of them will be forced to move by using a stronger force. So I want you to pause the video now and take a few minutes to draw some pictures showing either a push or a pull. So for example, a man lifting a weight. I want you to then label each picture as push or pull. Okay, so hopefully now you've drawn a couple of pictures. Here are some examples of what you could have done. So you could have drawn a person pushing a box. You could have drawn a person pulling a box. You could have drawn the first example I gave you of two people playing tug of war. What about a man doing a press up? You could have drawn a box on a table. You could have also drawn someone kicking a rugby ball or a football. You also could have drawn a magnet or even an arrow being shot out of a bow. So if you haven't already labelled your forces as push or pull, take a minute to label them now. Okay, so if we look, the first picture we have a person pushing a box. They're using a force to move the box along the ground. In the second picture, the person is still moving the box, but this time they're pulling it. So they're using a slightly different force. In the third picture, like we already talked about, we have two people that are pulling in opposite directions. The person that uses more force will eventually win by pulling the other person in the opposite direction. In the picture of the person doing the push-up, they are pushing their body up against the floor. We have a picture of a box on a table. This has two different forces, and you'll notice I've already drawn in some arrows. So you have a push and a pull force here. You have the pull of gravity holding the box on the table, but the table is also pushing up against the box. In our sixth picture, we have a push force. The person's foot is going to push against the rugby ball and hopefully push it enough to push it into the air. The pull force of the magnet pulls the nails towards the magnet. And finally, again, in our arrow and our bow and arrow, we have two forces. So we have the pull, so you're going to be pulling on the string to pull it back, and then that string is then going to push against the arrow and hopefully fly it into the air. So I'd like you to take another minute now, and I'd like you to draw in arrows on your pictures. In each arrow, you use it to show the direction that the force is moving. The bigger the force, the longer the arrow should be. So in my example here of the box on the table, you'll see the arrows are the exact same. We will look at this in more detail in a further video, but the reason they are the same is because the box is not moving. So the gravitational force is the exact same as the force of the table pushing up against the box. So take a minute now to label your diagrams. Okay, so here are the answers for the diagrams that I have drawn. So you can see the man pushing the arrow, it's going to be moving in a forward position, and the same with pull. You have the two arrows were already drawn in for the people playing tug of war. For the push up, or the press up, you have the force of gravity pulling the man down towards the floor, but you also have that bigger force of his muscles pushing him up. Right, so that's why you can see that the arrow going upwards is slightly bigger than the arrow going down. On our table, we've already talked about, we've got again two forces going in opposite direction, which stops my box from moving anywhere. In the football, again, we've got the arrow going up towards the sky. You can see the magnet, the direction that the nails will be pulled in because of the magnetic force. And then my arrow, so the string will be pulled backwards while the arrow moves forward. So how exactly do we measure force? So we use this device which is called a Newton meter. You can see it pictured there on the slide. Inside the Newton meter there is a spring, and this is connected to the metal hook that you can see holding the apple. The spring stretches when we placed any force onto the hook. The bigger the force applied, the longer the spring is stretched, and that means we get a bigger reading. So you can see on the Newton meter there's numbers from 1 to 10, and the bigger the force, so the apple being pulled down by gravity, gives us about a reading of 1.5. If we were to pull that, we would see that we could get a bigger reading depending on how big the force was. We use a unit called newtons to measure our forces, and we use the symbol N when we are writing it. So for example, on the bottom of the picture you'll see a car and you'll see two numbers. So the first one is 500 newtons. That tells us how much of a force as the car is driving is being moved against it. So the car is driving along the road, and imagine there's air pushing against it. That air has a force of 500 newtons. To make the car move forward, it needs to have a greater force than that. So you can see the car is moving at a force of 2000 newtons. The greater the force, the bigger the number. Right, lastly, I'd like you to pause the video one more time, and I'd like you to look at this link. This link links you to a website called BBC Bitesize, and I want you to have a look through that information and maybe create a few more diagrams based on some of the examples that they list in this link. Do the exact same thing, label them as push and pull, and then draw in your arrows showing the direction and the size of the force. Okay, an idea for an experiment that you could now do. For one full day, from the minute you wake up to the minute you go to bed, make a note of all the forces that you apply. Explain what would happen if you weren't able to apply those forces. Think about it. What would happen if you couldn't pull any door handle for the entire day? That's just one force. As you list down your forces, have a think about what would your life be like if you could not apply those forces. You should now be able to understand and explain forces, and you should be able to list loads of different examples of forces and draw force diagrams.